Space agencies have been stealing angular momentum from planets since decades through a maneuver called the gravity assist. I'm Saathvik Sundar, and this is the working of a gravity assist maneuver. Of course, planets don't feel the effect of this due to their huge mass. Jupiter is this much more massive than the spacecraft. It's like a housefly bumping into a train. Gravity assist was used in Rosetta, Juno, Cassini, Voyager 1 and 2, Pioneer 10 and 11, and a lot more space missions. The gravity assist speeds up, slows down, and or changes the direction of the spacecraft. How does it work? It's like a game of cricket or baseball. One can slow the ball or speed it up while changing direction, except the interaction is gravitational in nature. According to Newton's law of universal gravitation and Newton's second law of motion, as the spacecraft approaches the planet, it accelerates, and as it leaves, it decelerates by the same rate due to a change in the force. Direction changes at each point. Note that the trajectory is planned such that the field is strong enough for a significant influence but weak enough to ensure the spacecraft doesn't orbit the planet assisting. It's like a roller coaster. As you go down, you speed up, and you slow down by the same rate when traveling back up. Here, the transfer is mainly kinetic energy and momentum transferred between the bodies in accordance with the laws of conservation of energy and momentum. Well, what's the advantage now, you might ask? The key is that everything is relative. The above was from the perspective of the planet or for a stationary body, but our planets move in elliptical orbits around the Sun. Let's look at it from the perspective of the Sun. Since the planet is moving, flying past it along the direction of motion will propel the spacecraft further as the planet is dragging the spacecraft with it. A change in direction will change the velocity too, since velocity is a vector. Note the change in speed of Voyager 2. Traveling in the opposite direction will act like a drag or friction onto the spacecraft. Besides this, the analysis of velocity as a vector means that when we reverse the direction, increase or decrease gets reversed too, since it's all in the angle of the vectors. Notice the change in speed for Ulysses. In the case of the Voyager missions, without a gravity assist, they would have traveled this much, and with it, Voyager 2 has covered this much, and Voyager 1 this much, and they're still traveling. Thus, gravity assist is an effective way to propel a spacecraft further without cost, technological complexity, and propellant issues. Will this ever be used for manned missions? I don't think so. Its only drawback is that it's very time consuming, and most astronauts prefer spending their time back on the Earth. Overall, this maneuver has great weightage and potential in the space exploration field and will definitely be used in the future for space travel. I would like to thank Breakthrough Challenge for the opportunity, and I thank you for watching.